Hey, hello, welcome to the show. It's me, JP, and this is JP's product pick of the week, and we are here once again with a cool Adafruit product pick that I'm going to show you. And the first thing I want to do actually is jump forward in time to when you know what the product pick is, even though I'll pretend I don't yet, because that way I can head you to the product page where you will find a massive 50% off on this week's product pick. So head to this URL right here or point your device at that QR code. That's going to take you to the web page. And if you head there, you will see we've got 50% off, and I think it's a maximum of 10 per customer. I'm going to sneak on over there real quick myself, and I'm going to refresh this page. My goodness, yes, maximum of 10, and it is half price. What the heck? Also, by the way, you can watch this very video right inside of the product page. So do that. We recommend it. All right, that's enough revealing what's going on in our future. So now let's get back into the current time stream and have Lady Ada tell us a little bit about this week's product pick. Take it away, Lady Ada.
ItsyBitsy RP2040. This is the RP2040 based ItsyBitsy. So people like the ItsyBitsy inspired by teensy boards, but I wanted to have them with different chips. Bite-sized, but has lots of GPIO pins. The GPIO pins go all the way around. I want to show and compare. So you got the M0 Express, the M4, the Blue Fruit, and now new friend is made RP2040. So
for ItsyBitsy.
It's for, well, there's actually two more, the 32U4 ones, which I didn't even bring down because these are nice and popular. But what I tried to do is I try to make them sort of similar. I try to have like the NeoPixels over here, and you know, these have the buttons on the end. This, of course, has the antenna here, so the buttons have to move up. So the ItsyBitsy, if you want to have a LiPo battery, you have a LiPo backpack that you can use with it. This is a single-sided board. It has an 8 megabyte QSPI flash. It has the reset button. It has the boot button. I did the cute Pimoroni hack where the boot button is also a user button after booting. So when you're running code, you can use this as a single button input. It's got a little NeoPixel here. I wonder if I still have the NeoPixel on program. Yeah, I do. It's got one red LED for blinking. It's got the crystal, power supply, lots of little capacitors. I had to use a 402 components to make everything fit, but it did all fit in the end. And then on the bottom, we have the GPIO pinout. So this is if you're using it with Pico SDK or with MicroPython or something where you need to do the raw pin numbers. These are labeled on the bottom. And then there's one pin, D5, that's special purpose. And that pin is level shifted up to about 5 volts. So if you want to drive NeoPixels and you want a 5 volt output, there's just some times where people are like, I need to control something that's a 5 volt input. It really wants 5 volts, particularly NeoPixels. That pin is level shifted out to 0 to 5 volts. So you've got one pin over here. It's 5. It's got the exclamation point to remind you that it's the output pin. But otherwise, what's nice about the RP2040 is, it's a dual core Cortex M0. It's running at 130 megahertz. It's got CircuitPython and now Arduino support's coming out. MicroPython support. You can do Pico SDK, and he's got a lot of pins. And I made sure that you've got not only a lot of pins, but you got all the analog pins. There are 8 pins in a row if you want to do like camera projects where you use the PIO to drive 8 GPIO at once. They're not all in a row because I wanted to match like the SDA and SPI pin and UART and analog pins match the other ItsyBitsys, but they are available. You can get to all those pins if you want. They're just, if you look on the bottom, I think it's 26, 27, 28, 29, and then 24, 25, 18, 19, 20, whatever. Basically, you got lots of pins that are in a row, so if you want to use PIOs to drive many pins in parallel, you got it. And what's nice is that you can swap between the two. You got a project with an M0 and M4, you want Bluetooth, swap between it. You want RP2040, swap between that as well. So, this is one of the original RP2040 boards that we said we would design, and so we fulfilled it. We got the Cutie Pie, ItsyBitsy, and the Feather. So this is a great tiny board with lots of GPIO pins, and if you want, you can add a LiPo charger onto it by soldering on one of our LiPo backpacks.
All right, I'm convinced. I'm going to head over to my mystery cabinet of wonder drawers and go grab one. I'll be right back.
ItsyBitsy RP2040.
That's our product pick of the week this week. It is the ItsyBitsy RP2040. This is really a terrific board. It is small, and yet it's got more GPIO pins available on it than most any other board that we have. So, for example, way more than a cutie pie, but you knew that, right? This is meant to be small. This one's meant to be big. But then the Feather board, actually, while it has a lot of really great features, it has fewer available GPIO pins than this guy right here. You'll also notice that it's quite a bit smaller than a Pico, the equivalent RP2040 chip. So this little board here, what I want to do first of all is have you jump over to the page here where, let me switch camera views, where you can go and pick one up. So I mentioned this before, if you refresh right now, you're going to see this is a $4.98 for an ItsyBitsy, which is terrific, incredible price. If you take a look in here, you'll see some info about the board, a lot of its stats. So important stats on this. It's we've got a boot and a reset button on it, so it's really easy to get into bootloader mode and deal with that without adding any extra pins like you would with a Pico. It's got 8 megs of flash on it, which is terrific. So sometimes you're wondering what chip you should use or what board you should use. A Cutie Pie is going to have less RAM to work with, and in the case of the ItsyBitsy, you've got so much RAM on there that you can just pile on the libraries. Of course, it's got the speeds of a Cortex M4, but it's a dual Cortex M0 design, and there are 4 analog to digital converters on there, 4 ADACs, and then you can use 23 pins as digital I/O pins if you want. And as Lady Ada mentioned, this is a teensy form factor board, so you'll find there are a lot of cases where particularly in the keyboard community, where the Pro Micro and the Teensy are 2 similarly sized boards that are really popular. So this fits kind of in that category of really small, dense board with lots and lots of pins on it. Particularly great for projects where you don't need to use a LiPo battery. It doesn't have that LiPo charging circuit on it. You can add on a LiPo backpack if you want. If you take a look, if you scroll down here and head to the Learn Guide link down towards the bottom, you can jump right there right now. You'll find we've got this nice guide from Kattni, which tells you all about the board, gives you the pinouts for it. So if you want to dive in a little bit deeper, you can take a look at this. One nice thing about this board is that it has the pinouts on the top of the board, on the silk screen that you would use for things like Arduino and CircuitPython. Also has on the bottom the GPIO pin names that you would use in MicroPython. So you have sort of a reference there for any of that information. As Lady Ada mentioned, there's a special pin on here, pin 5, that gives you a 5-volt logic level. So for things like NeoPixels, particularly if you're doing some sensitive stuff with NeoPixels and you want to make sure that you get accurate data, you can use the 5-volt coming off of the V-in pin if you're plugged into USB or another 5-volt source, as well as that D5 pin, and that'll give you the 5-volt logic, which is really cool. It's not a lot of boards that do that. And then there's CircuitPython info on this. You can also use Arduino using, there's a Arduino Core that's working on this now, and you can use MicroPython, but I'm using CircuitPython in the example that I'm going to show here. So let me switch to my overhead here, and there's the board there. What I'm going to do is I'm going to refocus, and I'll show you a little project that I put together. Because you may ask yourself, well, what kind of project would I want lots and lots of GPIO pins for in a small form factor? Well, I will answer that with this. This is a MIDI key bed It's actually a key bed. It's not necessarily MIDI. It's a synthesizer key bed that I pulled out of an old synthesizer. Now, all this really is a diode matrix keyboard, and it turns out it's an 8-column and 8-row diode matrix. So that means I need 16 pins plugged into my ItsyBitsy. I've got 16 pins to plug into the ItsyBitsy. In fact, I've kind of got 8 across the top and 8 across the bottom, so I can sort of match the wiring of this keyboard. And I have some leftover pins that I decided to plug in a little NeoPixel strip here. And what I'm doing is I'm reading that using our keypad library. I can read the diode matrix and know which keys I'm pressing. And then you can use that for kind of anything you want. So you could turn that into HID stuff, game stuff, pure digital control of NeoPixels. I decided to have it send off MIDI commands to my computer. I'm just running some synth software that'll read those MIDI commands. And at the same time, I'm also going to send commands to my NeoPixels to light up little chunks of these NeoPixels. So let's see, we should be able to hear this. So you can see there, it's a whole lot of fun to play sort of moody, Blade Runner-y types of pads with this, especially if you stick to the white keys, if you don't really know how to play the keyboards like me. But you see here, we've got some really nice fast response polyphony, so our keypad library can deal with reading lots of keys, all the keys at once, basically. We could mash this and it knows they're all pressed. And I have this NeoPixel strip that is no compromise, plugged into 5-volt logic, plugged into 5-volt power, which is terrific. Let's take a look. Now you can see here, I'm just in the prototyping phase of this, so I've got my, let me go ahead and adjust some lighting on here real quick. I can boost the exposure there. That's a little better. So you can see I've got my little ItsyBitsy plugged into a small breadboard there, and then I'm breadboarding these wires into, I'm going to flip this over and probably wreck things in the process. But you can see the bottom of this keyboard. In fact, you can see the keyboard matrix diodes there, and this gives me a little bit of a clue of how it's wired, although some of that I opened up the circuit board and looked at the traces to try to figure out the column and row situation. All of them come off of this little IDC connector here. Jumper set here, 16 jumpers, and I'm going over an IDC ribbon and then plugging into my my little breadboard there. I'm also putting some LED acrylic across there so that it's not quite as bright. And that's about it. I'm powering it off of micro USB. Now, in the final version of this, I may put it on a Perma Proto board, make that wiring really short and concise, and be able to fit it right up in this space. So there's definitely enough space in here. I may cut a little notch in the side to put my USB connector, but now I've got a sort of ready-made hackable keyboard that I can use for just about anything. I could create a synth on board, power a Music Maker Featherwing, just use it for USB MIDI stuff, use it for classic MIDI stuff. But I've been waiting on this. You might remember I showed this little keyboard that I pulled out on social media, at least, and maybe on my show a year or two ago. And it was just yesterday that I thought, hey, you know what? Here's a perfect use for this ItsyBitsy, given all of the GPIO pins that it has. So that is, I think, a fun way to use this, but the sky's the limit. You can really come up with a lot of interesting ways to use a powerful little board. It's running that RP2040 chip, which is inexpensive, fast. We've got lots of flash on there, lots of GPIO pins. Can do CircuitPython on there all day long, and it is half off right now. So I'll remind you again, if you head over to this URL, the product number is 4888. So if you head over there, you will get this really wild discount just during the show. So load up your cart. You might have a little bit of a grace period after the show ends, but once it's in your cart, don't hesitate too long. Hit buy. We've got a maximum of 10 per customer, and you will be able to do all kinds of projects like this with the keyboard or anything of your own devising using all that great juicy GPIO. A couple questions from the chat over in YouTube chat. Charles Burnford asks, what keyboard did it come from? This was a very old M-Audio Oxygen, which was a MIDI controller and I think it had a mic, a phantom mic in, so you could use it as a little bit of a mixer, like audio input. It had some problems, one of which being the drivers just ceased being updated and stopped working with versions of Mac software years ago. It was a really old keyboard. So I decided to pull a few parts from it, including this neat little keybed. But these things are all made by just a few companies, and you can pull them out of pretty much any thrift store keyboard you find. There'll be a little membrane underneath with little carbon pads. One interesting thing about this is actually there are two, let me show it while I'm talking about it. There are actually two switches per key. So this is actually capable of doing velocity sensitive velocity sensing, because when you press a key, it's actually 1 and 2 little switches that get pressed every time. And so if you're able to calculate the difference between how quickly those are pressed, that's how velocity is sensed on a lot of these keyboards. It's just a differential between those two buttons being pressed says you hit it slowly because it took a while for the second button to get hit, or it was really fast because they were nearly instantaneous. But yeah, any thrift store keyboard you find is really, really, really likely to be a diode matrix like this, and depending on how big it is, this one being an 8x8 matrix, it could do up to 64 keys. This is actually 25 physical keys, but because of the velocity sensitive switch, it's actually 50. The matrix that we're reading is actually 50 different items. I'm throwing away half of that because I don't need half of those to do what I'm doing, which is this very simple non-velocity sensitive thing. And other questions, by the way, I'll say thanks for stopping by in the chat. We've got our Discord chat over here. If you want to go join that chat, you can head to adafruit.it/Discord. You get an instant invite, jump in, and that's where the party's at. That's where people are hanging out and chatting over in the live broadcast chat channel in particular. And let me just scroll back a little and see if there's any other questions. Oh yeah, someone asked me about the Blade Runner 2049 thing. I finally realized what it was about RP2040 that was kind of tickling the back of my Android brain, and that was the 2049 reference in the movie. It's kind of similar numbers, so that's why that happened, if you're wondering. Let's see, other questions? I think there's some discussion about doing the velocity sensing thing. Let's see. Yes, Arduino Core, that is the Earl Philhauer Arduino Core. If you want to run Arduino on these RP2040s, it works really well. Yes, these keyboards will work with Linux just fine. Pretty much anything that you can use USB HID or USB MIDI on, you can tell the ItsyBitsy RP2040 to send those kinds of commands. Yes, Todd and Katney were talking about convincing Dan H to add a millisecond tick timestamp to the keypad library so we could do velocity sensing. That would be cool. It'd be really cool. Okay, well, I think that's it. Let me know if there are other questions. Charles Burnford says he has a V2 Oxygen. All right, so maybe you recognize the keypad there. Good for Haunt hardware. Yeah, Holosuite, that's right. We got Halloween coming up, and there's probably a lot of different Haunt applications for something like this. Again, like I said, unlike a Feather, it doesn't have the LiPo battery charging and connection built right onto it, but you generally don't need it for those types of permanent installations where you might just plug it into a USB power brick to power it or some other voltage source. All right, I think that's gonna do it. So let me jump back to the main camera here. That is my product pick of the week. It's the ItsyBitsy RP2040. It is a powerhouse little board. I love it so much. I'm gonna go ahead and put that on my new product pick board, and that'll do it for today. So again, head to this URL if you want to go pick up 1 or 10 of these at half price. Only now, while this show is on, you can throw those in your cart, get the discount, and off you go. Let us know in the chat what kinds of things you build with them. We're really looking forward to all kinds of things, in particular your Halloween haunts. That's gonna be a lot of fun. All right, for Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Bye-bye.